The next experiment that you're going to do is the relative reactivities of aromatic compounds. So we're getting really into second semester stuff now. I tend to spend a lot of time on electrophilic aromatic substitution. And so activating compounds, deactivating compounds, electron withdrawing groups, electron donating groups, all of those things come into play when you're looking at the reactivity of aromatic compounds. Now we're focusing on 3 compounds in order to compare the reactivities of different functional group substitutions on those aromatic rings. So you have 3 different starting materials. You have acid anilide, which is an acetoamido group. You have anisole, which is a methoxy or alkoxy group. And you have aniline, which is an amino group. Now, if you reference your textbook or any online textbook for this material, you can get an idea of the relative reactivities of these beforehand. So I suggest that you do that. The way that we determine the reactivity is through the melting points of the compounds that are made. So the compounds that are made in this reaction are unknown. You use the melting points to determine what the identity of those compounds are. So we've given you a list of melting points of possible compounds. We're reacting those 3 starting materials with HBr and bromine, which is going to brominate the ring. How active the compound is going to determine how many bromines we add around that ring. Now, one thing that I will say is that all 3 of these groups are orthopara-directing. So it's going to limit somewhat the products that you're going to make. You're not going to get any meta-substitution. So the key to this experiment is use the melting points to determine the proper product. That is going to give you a relative relationship between the 3 starting materials in terms of which is the most activating group, which is the least activating group. Then you're going to determine your percent yield. So first you have to figure out what your product is, and then you can do percent yield calculations. So make sure you determine your product first before you do the rest of those calculations.